To class, this is our Monday, April 20th. Now I know not all of you are able to get your homework in so far, but remember, so far we've done 12.1 through 12.5, the chapter 12 test, and 13.1 through 13.5 and 13.7. So if you haven't turned that in, turn it in just as soon as you possibly can. And this is the test review for chapter 13 on Monday, April 20th. So just keep up the good work and try to get that homework in, and everything's going to be great. I know we're going to end up early. So for this test review, for the first question, 5 flights from Buffalo can connect with 4 flights from New York to Denver in time for 3 flights to Cheyenne. How many flight paths are possible? Well, this is just a combinations of how many possible, so it's 5 times 4 times 3, or 20 times 3, or 60. Now, problem 2, how many ways can the letters of algebra be arranged? Now, there's 7 letters in algebra, but there's 2 A's. So we account for that by saying 7 factorial over 2 factorial for the A's. So that will leave us with 7 times 6 times 5 times 4 times 3 times 2 factorial over 2 factorial, or multiplying that out to 2520. Now problem 3, how many ways can the positions of center midfielder, left forward, and sweeper be assigned from a 12-man soccer team? Well, that would be 12p3, because the order would matter here. So the way we do permutations is 12 factorial over 12 minus 3, or 9 factorial. And the 9 factorials would cancel out, as you see, so it'd just be 12 times 11 times 10 times 9 factorial over 9 factorial, or 1320. Now this is a binomial problem, so this is going to be 2x minus y to the 5th power. So we want to look over at our Pascal triangles for n equals 5, and the coefficients, as I have circled, is 1, 5, 10, 10, 5, 1. The last one and the first one is always 1. So here we go. 5c5, 2 parentheses 2x to the 5th minus y to the 0 power, which is 1, which turns out to be 1. 5c5 is 1, and then 2 to the 5th at 32x to the 5th. So that's the first term. Plus 5c4, 2x to the 4th, negative y to the 1. And that's 5c4 is 5, 16 to the 4th is 16, x to the 4th times negative y, which 5 times negative 16 is negative 80 x 4th to the y. That's the second term. Plus 5c3, that's the 10, 2x to the 3rd, which would be 8x 3rd, times negative y squared, or plus y squared. So that would be 10 times 8, or 80, x to the 3rd y squared for the 3rd term. Now the 4th term, 5c2, is also 10, and that's times 2x squared, or 4x squared, times negative 3 squared, which turns out to be a negative 3, negative y to the 3rd, rather. And so that becomes negative 40 x squared y to the 3rd, because it's the negative for the y and the odd power. Then 5c1 is back to 5, and that gives us 5 times 2x times negative y to the 4th, which gives us positive 10 xy to the 4th. And above there is the last one, 5c0, which is 1 negative y to the 5th. So that's minus y to the 5th. So here's our answer. 32x to the 5th minus 80x 4th y plus 80x 3rd y squared minus 40x squared y 3rd plus 10x y 4th minus y 5th. Now problem 5 is if probability of A is 0.2 and probability of B is 0.5, then the probability of A complement is 1 minus probability A, or what's left over from 1, which is 1 minus 0.2, or 0.8. Now part B is probability of A and B if A and B are independent. And if they are, then we can just multiply the probabilities. So PA and B is equal to PA times PB, or 0.2 times 0.5, which is 0.10. Then we want to know PA or B. If A and B are mutually exclusive, they have no overlap. In that case, you just simply add them. So PA or B is PA plus BB, which is 0.2 plus 0.5 equals 0.7. Now for the next group, we want to find each probability to the nearest 0.1%, so that's 3 decimal places, when randomly drawing from a hat the letters of the alphabet, so 26 possible. So now, what's the probability of drawing one of the 5 vowels, A, E, I, O, U, in a single draw? Probability of picking a vowel is 5 over 26, or approximately 0.192, which is 19.2%. Problem 7, drawing one of the vowels and one of the other letters, which is a consonant, with replacement. So that means we put what we choose back in. Okay, and so, but we must take account of both orders that it happens, a vowel first and a consonant, or a consonant first and then a vowel. So if it's a vowel first and a consonant, it would be 5 over 26 times 21 consonants over 26, because we put our vowel back in. And plus, the consonant first, then the vowel, just changes up the numbers on the top. 21 over 26 times 5 over 26. And really, they multiply out to the same fraction, so it's just 2 of them. So it's 105 over 676 plus 105 over 676, which would be 210 over 676, or to 3 decimal places, 0.311 rounded, which would be 31.1%. Now, problem 8 was the probability of drawing 2 vowels or 2 consonants, now without replacement. That's where we drop one on the denominator each time. So the probability of the first being a vowel and the second being a vowel is 5 over 26 times 4 over 25, plus the probability of the first being a consonant and the second being a consonant would be 21 over 26 times 20, one less consonant, over 25, one less total. So that would multiply out to 20 over 650 plus 420 over 650, adding up to 440 over 650, which is 0.677 to 3 places, or 67.7%. Now, what's the chance of drawing exactly 3 vowels in 6 draws with replacement? Well, here we would use our binomial theorem, 6C3, 5 to the 26 to the third, that would be 3 vowels, and 21 over 26 to the third, that would be the 3 consonants. So now 6C3 is, remember, 6 factorial over 6 minus 3, or 3 factorial, divided by 3 factorial. So the 3 factorials cancel out, and we have 6 times 5 times 4 over 3 times 2 times 1, or 120 over 6, which is 20. So now our 6C3 becomes 20 times parentheses 5 divided 26, close parentheses, power 3, that's how you do it on the calculator, times left parentheses 21 divided 26, close parentheses, power 3, comes out to 0.075 to 3 places, or 7.5%. Now 10, what's the chance of drawing 3 or more vowels in 6 draws with replacement? So that would be 1 minus, because we're going to use the complement idea. 3 or more vowels would be 1 minus not picking 2 vowels or 1 vowel or 0 vowels, because those would be not the case for 3 or more. So we're going to do the binomial expansion for the 2, 1, and 0. So 1 minus bracket 6C2, 5 over 26 squared, and 21 over 26 to the fourth, plus 6C1, 5 26 to the 1, and 21 26 to the fifth, plus 6C0, 0 vowels would be all consonants, 21 26 to the 6. So 1 minus parentheses, 6C2, as you can see over here, is 6 factorial over 6 minus 2, 4 factorial, divided by 2 factorial. The 4 factorials cancel, and it's 6 times 5, 30 over 2, or 15. So 1 minus, now you can do this all in one line on the calculator, it'll wrap around. 1 minus parentheses, 15, then left parentheses, 5 divide 26, parentheses, power 2, times 21 divide 26 in parentheses, power 4, plus 6c1 is 6, 5 divide 26 in parentheses, times 21 divide 26 in parentheses, power 5, plus 21 divide 26 in parentheses, power 6, and then close the parentheses for the whole string of binomials. So what we're looking at it now, we should get 1 minus parentheses 0.236 plus 0.397 for the 1 vowel and 0.278 for the 0 vowels. So adding those up, we get 0.089 and to 3 places, and that's 8.9%. Now we're going to omit 11, 12, and 13. And now 14 is assumed for baseball. The last season's batting average had a mean equals 0.253, which is not too bad for a baseball player, and standard deviation, the sigma, equals 0.12. So what interval of batting averages contained the middle 95% of players? And that would be from mean minus 2 standard deviations low to mean plus 2 standard deviations high. And that's easily calculated as mean 0.253 minus 2 times 0.012 would be a low of 0.229, and mean plus 2 sigma would be 0.253 plus 2 times 0.012, which would be 0.277 for the high. So the middle 95% of players would be between 0.229 and 0.277. Now 15, what percentage of ball players had a batting average of at least 0.265 using the same mean and standard? So we have to get a z-score here. Z is equal to 0.265 minus 0.253 over 0.12, or 0.12 over 0.12, which is just 1 standard deviation. So that's 1 above out to, let's say, 4 above, so we catch everything on the right side. So more than 1 is really the right half minus 34%, because from the mean to 1 standard deviation above is 34%, so everything that's left would be 50 minus 34, or 16, and if you add up all the pieces, you can see it'd be 13.5 from 1 to 2, plus 2.35 from 2 to 3, and 0.15 on, which still adds up to 16, but 50 minus 34 is an easier way. So we're going to omit 16 and 17, and now on this set of 8 numbers, 79, 83, 84, 84, 85, 91, 99, 99, the median for 8 is artificially in the middle of the 4th and the 5th, and the Q1 is the median of the bottom 4, which is in between the 2nd and the 3rd, and the Q3 we see is the artificial number between the 6th and the 7th, halfway in between. But before we need that, we need the modes. So the mode, 84 repeats twice and 99 repeats twice, so we have a tie, because both have 2 repeats. Now for the mean, we have to add all the numbers up and divide by 8. So 79 plus 83 plus 2 times 84 plus 85 plus 91 plus 2 times 99 is 704 over 8, or a mean of 88. Okay? Now on 19, I already indicated that the median is halfway between the 4th and the 5th, or 84 plus 85 over 2, which is 84.5. The Q1 is halfway in between the 2nd and the 3rd, or 83 plus 84 over 2, which is 83.5. The Q3 is the 6th and the 7th averaged, which is 91 plus 99 over 2, which is 95. The IQR is the Q3 95 minus the Q1 83.5, or 11.5. Now the 5 number summary here is the lowest 79, the Q1 83.5, the Q2 median 84.5, the Q3 75th percentile 95, and the highest number 99. And that's the 5-number summary which we make the box plot for over here. So we see 79 is the low, the left part of the box is 83.5, the right part of the box is right near, or the median is right near the left, Q1, Q2 is 84.5, so 83.5 and 84.5 are real close. And then Q3 is the end of the box at 95, and then the high goes out to 99. And the last problem is to find the standard deviation for these 8 numbers, remembering that the mean is 88 from the last problem. And so remember how we do this. We take the numbers in the xi column and we subtract each one from the mean. So 79 minus 88 is negative 9, 83 minus 88 is negative 5, 84 minus 88 is negative 4, 85 minus negative or 88 is negative 3, 91 minus 88 is 3, and the 99's minus 88 is 11. Then we squared those. 9 squared is 81, 5 squared is 25, the 4 squared is 16, the 2, negative 3 and 3 squared is 9, and the 11's are 121. So we add these all up, 81, 25, 2 16s, 2 9s, 2 121s, and they add up to 398. Remember, our variance is the summation of those 8 squared differences divided by how many? So 398 over 8 is 49.75, and the standard deviation below it, sigma, is the square root of that, which for us is 7.05. So God bless and do great on your test and get caught up on your homework.